So the computer vision team 1 consists of me, Francine, Hannah, Maddie, Rosie, and Sophie. Next slide, please. Last semester, we tackled the problem of generating a label computation dataset that can be used by another subteam to train an obstacle detection neural network. To achieve this goal, we had like 4 small things we need to do. We needed to 1, distribute raw images to team members for labeling. 2, develop an application to label images. 3, verify the labels that they're correct. And 4, export them for training a neural network. And now Hannah will talk about the tools we used.
Okay, so to achieve our goal, we first customized an open source application called Label Image. So first we set up a web server to store our image data, and then we use this to coordinate the image distribution and labeling across different computers. So using a login feature that we added to this app, MuddSub members were able to access a set of unique images that we assigned to them to label. Then inside the application, users were able to draw bounding boxes, such as the screen one that you see in the image, and then assign the appropriate label to each visible object. Then labels and bounding box coordinates were uploaded to the server and saved. And once all images were labeled through a collective MuddSub effort, we ran them through a verification process and manually corrected any mislabeled or misplaced bounding boxes. And then after this whole process, after all images were labeled and verified, we were left with the set of image and label data that we could pass on to the other computer vision team for them to train their neural networks. And now I'll pass it on to Sophie to talk a little bit more about other things we have been working on.
So now that we have wrapped up the image labeling project, we have moved on to our new task, depth estimation. On the right, you can see a robot's input image above and its generated depth map below. At the moment, we are working on a literature review and strategy comparisons. We are considering approaches involving different numbers of cameras, whether to use neural networks, and spatial versus temporal analysis, which means computing distance using images from different positions versus different times. Moving forward, we need to obtain a data set, which can be difficult for underwater images, and implement our chosen approaches and compare results.